In this video, we're going to learn how to solve a trigonometric equation, linear in sine and cosine. So we're going to solve each equation on the interval of 0 to 2 pi. So when I look at sine plus cosine, there's no immediate way to factor this, and it's equal to 1, so there might not be a way of combining them into the same trig function. So what I'm going to do is show you two strategies for approaching this problem. The first being that we could just square both sides of the equation. Now there's one thing wrong with this particular strategy, is that now I'm changing the properties of the equation by squaring, which means I could have an extraneous solution, meaning a solution that doesn't actually work in the equation. So I'll have to keep that in mind as I go through the rest of this problem. So here when I square this, I get sine squared of theta plus 2 sine theta cosine theta plus cosine squared theta is equal to 1. So I see here I get sine squared plus cosine squared theta, which is the Pythagorean identity. So together that gives me 1. So I end up with 2 sine theta cosine theta plus 1 is equal to 1. So I can subtract 1 from each side, and I get 2 sine theta cosine theta is equal to 0. So now I have factors that I can set equal to 0. After I divide by 2, I see I have sine theta times cosine theta is equal to 0. So either sine theta is equal to 0 or cosine theta is equal to 0. And all the solutions on the interval that make this happen, sine of theta is equal to 0 at pi over 2, 0 and pi, and cosine is equal to 0 at pi over 2 and 3 pi over 2. Now I have to check all of these solutions to see which ones work and which ones don't. So I'm going to go back to the original equation, and I'm going to plug them in to check. So sine of 0 plus cosine of 0 gives me 0 plus 1, which is 1. So that works. Now let's try pi. I have sine of pi plus cosine of pi, which is equal to 0 plus negative 1, which does not equal 1. So we cannot use pi as a solution. Now we have sine of pi over 2 plus cosine of pi over 2, which is equal to 1 plus 0. So that equals 1. And then we have sine of 3 pi over 2 plus cosine of 3 pi over 2, which is equal to negative 1 plus 0, which does not equal 1. So we only have two solutions that work, which would be 0 and pi over 2. Now, this could be a little burdensome sometimes because you have to check every single time, but there is an alternate way to solve this, which is usually the more preferred way for linear equations like this. What I mean by linear equations, if you imagine this being like ax plus by equals c, it's like standard form, but instead of x and y, we use sine and cosine. So linear in sine and cosine. But now what I want you to do is divide each side by the square root of 2. You may be wondering what this will do. So I'll get 1 over square root of 2 sine of theta plus 1 over the square root of 2 cosine of theta is equal to 1 over the square root of 2, which when I rationalize gives me square root of 2 over 2 sine theta plus the square root of 2 over 2 cosine theta is equal to the square root of 2 over 2. Now, it seems that I did this very randomly, but I now have two things being multiplied with a sine function and two things being multiplied with a cosine function. So if I were to pick, let's say, another angle variable, so say we'll use phi, and I set phi equal to a particular angle. The reason why I'm bringing this up is set up in mind with the sine sum formula. But I don't know what to pick for this other angle yet to make that happen. So I'm going to look at the sine, and we'll just say of theta plus phi, because this is a plus sign. And this is equal to sine of theta cosine of phi plus cosine of theta sine of phi. So I need to know what angle phi makes cosine equal to the square root of 2 over 2 and sine equal to the square root of 2 over 2. That angle is pi over 4. So what this expression can become is the sine of theta, but now I can use cosine of phi, which is pi over 4. I'm trying to figure out what this other angle would be. And then plus cosine of theta times sine of pi over 4 equals square root of 2 over 2. So now I have this formula set up, but now instead of phi, I can use pi over 4. So it's just now becomes sine of theta plus pi over 4 is equal to the square root of 2 over 2. And now I have not altered the equation by squaring. I have just multiplied each side by the same value, so I shouldn't have any extraneous solutions when I go to solve this. Because now I know the two angles to make sine square root of 2 over 2 would be pi over 4 and theta plus pi over 4, 3 pi over 4 for the two solutions that make sine equal to the square root of 2 over 2. Solving both these equations, I can get theta is equal to 0 and theta is equal to pi over 2, which were the two solutions that worked. So the big idea behind this technique is to try to get values in front of the cosine functions that are values you know on the unit circle, so you can find that common angle. So let's try this trick over here. Here I have the square root of 3 in front of cosine, which if I were to divide that by 2 would be square root of 3 over 2, which is a value of sine in the unit circle. And when I divide by 2, I get 1/2, which is the value of cosine in the unit circle. So when I go to solve this equation, I'll divide each side by 2, so I get 1/2 sine of theta. I'm going to box this off so it doesn't get in the way. Minus square root of 3 over 2 cosine theta is equal to 1/2. I'm going to divide everything by 2. So now I need to figure out what makes cosine, what angle, if I think of that phi angle again, makes cosine 1/2 and makes sine phi equal to square root 3 over 2. And this is if I use the formula sine of theta minus phi, since I have a minus symbol between them. We know this is sine of theta cosine phi minus cosine theta sine phi. So what angle does that? Well, if cosine is equal to 1/2 and sine is equal to square root of 3 over 2, that's definitely in the first quadrant. And this phi is going to be equal to pi over 3, since that's where cosine is equal to 1/2 and sine is equal to square root of 3 over 2. So I can rewrite this as sine of theta cosine of pi over 3 minus cosine of theta, sine of pi over 3 is equal to 1/2. So now I can rewrite all of this as sine of theta minus pi over 3 is equal to 1/2. And I just have to find the two angles that make it equal to make sine equal to 1/2, which would be at pi over 6 is one angle. And the other angle is 5 pi over 6. So two angles on the unit circle make sine equal to 1/2. And you can find them here and here if you want a visual about roughly reference-wise where is equal to sine is equal to 1/2. Solving both of these equations, I can get 3 pi over 6 and 7 pi over 6, which just simplifies to pi over 2 and 7 pi over 6. So it requires a little bit of imagination, but this is how you solve a trigonometric equation linear in sine and cosine.